back to the classes. How are you all? I hope you all are good. You all are doing very well. So, students, what we are going to do is that we are just going to continue with the same chapter with the same topics, but it's just that in the last session we have discussed about the metals, but now we are going to discuss about the chemical properties of non-metals. So, do you remember that in the chemical reactivities of metals, what we have studied? So we have seen the reaction of metals with the oxygen, then we have seen the reaction of metals with the oxygen, then we have with the acid, then the reaction between the metals and metals. So we have seen all of these things. Then the reactivity series also. Water, the reaction of metal with water. So we have covered up all such things. Fine. Now students, we are going to see the non-metal reaction. Okay. So these are the topics which we are going to cover up in today's class. It's like chemical properties of non-metals. Oh, I'm so sorry. Actually, I haven't selected my pen. Now it's fine. So it's like chemical properties of non-metals, reaction of non-metal with there, and then we are going to discuss that what are the uses of metals. So students, what happened that the non-metals are having very less reaction as we talk about, like very less. Okay, now how they are reacting, what's going on here? So we'll see it here. Fine. So I hope you are watching all of these sessions or not. Just tell me one thing. Are you watching all of these sessions? If you are watching, that's good because like step by step with this session only you are covering up each and everything. So now first of all, for the non-metals, like if we have already discussed that what are the non-metals. So non-metals are students electronegative in nature. What? That they are electronegative in nature. That means they accept the electron so that they can form the negative ion, and that we called as the anion. Exactly, like if I talk about chlorine. So in the case of chlorine, students, it is Cl. That means its atomic number. Fine. Its atomic number is 17. So if I fill it up here, so it is KLM. That is 2, 8 and 7. Fine. Now students, if I see that what it requires, so I know this thing that when I give one electron to it, so it will come to 8. That is the 2, 8, 8, and that's how students Cl, by gaining one electron, it converts into Cl negative, and that's why we call it as the anion. Now, due to this electronegativity, actually, you have to see that whether the non-metals are reacting or not, or which type of reaction they are giving. Fine. So, students, in the last session, we have seen that the metals and metals are reacting with each other. It's just that it depends upon the reactivity, that the metals, which is more reactive in nature, it is going to displace the less reactive metal. Exactly. Do you remember this reaction, that the copper plus iron sulfate or iron sulf oh sorry, if it is like this, so you can see here, if it is iron and it is reacting with the copper sulfate, it is iron reacting with the copper sulfate and giving the reaction. So which one is correct here? So yes, definitely iron can replace it. That is FeSO4 plus copper, because iron is more reactive than copper. That means a reaction between metal and metal is possible. But if we talk about the reaction between non-metal and non-metal, so will it be possible to do? Will it be possible? So that's the whole point which we have to see here. So students, non-metals and non-metals do not react with each other. If they are reacting with each other, so what happened? Like you have to give some type of condition to them. At room temperature, they don't react. Fine. So that's a student. Non-metals do not react with each other, and even though non-metals do not react with air in the room, like at the room temperature as well. Fine. So that's how we are going to see the chemical properties of non-metals. So now this is the first reaction of the non-metals, that how they are reacting with air. So air is what? Air is containing oxygen. That means we are going to see the reaction of non-metal with oxygen. Now it's a very important thing, student. What important? That if you remember that how the metals are reacting with air, that if it is a metal, and if it is reacting with oxygen, so definitely it is forming metal oxide. And that metal oxide, if we do the litmus test for it, litmus paper test, and if there is a red litmus, so it converts it into blue. and the blue one remain blue. So that's the whole condition. If it is giving the blue, so that means it is what? It is basic in nature. Fine, students. That is how in that case of the metals we are getting the basic oxide, but we have studied about the amphoteric oxide as well. But now if we see that how the reaction of the non-metal is going on with the air, with air. So it's like non-metals react with oxygen to form non-metal oxide, but these non-metal oxides are acidic in nature. As you can see here that non-metal is reacting with the oxygen forming non-metal oxide, and this is acidic in nature. How you are getting to know that it is acidic in nature? So you can do litmus test. Okay, and if that test is giving like the blue one, the blue litmus paper is converting it into red. So definitely it is acidic in nature. Fine, students. So that's how we can see in the example that sulfur. Sulfur is what? Sulfur is non-metal. Now, how the sulfur is non-metal? Because we know this thing that this is sulfur. Fine. And sulfur, if we talk about its atomic number, so it is atomic number is 16. Okay, that means KLM. So it would be 286. That means, student, it has to accept 2 electrons so that it can attain the stable configuration. So that's how it is the non-metal, because it is accepting the electrons. Fine. And if it is a non-metal and if it is reacting with oxygen, so it is forming what? Sulfur oxide, sulfur dioxide, sorry, and this sulfur dioxide is acidic in nature. Fine, it is acidic in nature. Similarly, students, when the carbon is here and carbon reacts with oxygen, so it converts it into carbon dioxide. Carbon dioxide is also acidic in nature. Why? Because if the water is here there and water and carbon dioxide react, so it form H2CO3, that is the carbonic acid. So that is why these oxides, these acidic oxide which result into the formation of acids, we call them as the acid anhydrides. Acidic anhydride, you can say also acidic anhydride. Fine, students. But students, as in the case of the metals, we are having the amphoteric oxide. So when we talk about the reaction of non-metals with air, so we are having some neutral oxides. Okay, or we are having some oxides which are also not either acidic one nor basic one. So how they are? So look at here. For example, when carbon is reacting with the oxygen and the supply of oxygen is insufficient, so that reaction converts the carbon into carbon monoxide, and carbon monoxide, student, is not exactly the acidic one, because in that condition it is not it is not forming complete carbon dioxide, and carbon monoxide is a neutral oxide. We call it as neutral one. Similarly, if it is hydrogen, hydrogen reacts with oxygen, like hydrogen is there and oxygen is there. If we see, that is 2H2 and O2, so it converts into H2O. Okay, so again, students, we know this thing that H2O is what? H2O is liquid. Exactly. So that's how it is also not acidic in nature. It is neutral one. So that's why, students, some of the non-metals are there, which forms the neutral oxide as well. Fine. So that's how we can see that some of the non-metals are there which forming the acidic oxide, but some of the non-metals are there which do not form the acidic oxide. They generally form the neutral. Okay. For example, carbon. When carbon is burning in the insufficient oxygen, so there is the formation of carbon monoxide. Carbon dioxide means it is having 2 oxygen. Carbon monoxide means it is having 1 oxygen. And it is due to insufficient supply of oxygen, and that's why it is not acidic in nature, it is neutral one. And similarly, if you talk about hydrogen reacting with oxygen, because hydrogen also comes under the category of non-metal, so that's how it is also forming the neutral one. Fine, students. Okay, so that's the whole point, that how the non-metals react with air. Now, if we see that non-metals reacting with water or acid, so they don't react. Why, students? Because if they have to react with water, so they have to replace the hydrogen, and they are not reactive than hydrogen. Okay, so that's why they generally don't react with water, and that's how, student, they have to give, like, for that condition, then what they have to do is they have to give their electron to hydrogen, which is not possible for them. Like the metals are giving their electrons. What's the condition with the metal, students? If I say, when metals react with water, so they give their electron to hydrogen. Okay, they give their electron to hydrogen. But when there is some non-metal and they have to give electrons to hydrogen, which is not possible, because what's the tendency of non-metal, that they have to accept the electron according to their nature. So how they are going to give any electron to them? Exactly, because they need that electrons. So that's how, student, they will not give their electrons to hydrogen, and that's how they don't react with the water. Fine. So that's how, this is the only reaction which is in your syllabus, that how the non-metal react with air. So that's how oxygen, and they give acidic nature, but some of like carbon monoxide and water, so they are neutral oxides. Okay, fine. Now we are going to discuss about the uses of metals. So students, what happened, that the uses of metals. So generally the uses of metals depend upon their physical properties. Like if we talk about that, they are hard in nature. So generally when we require something which should be strong, that its tensile strength must be strong, like bridge formation, or we can say that the construction of buildings. So we use iron. So why? Because the iron is hard in nature, like it is very strong, it is not going to be destroy easily. So that's how we use metals according to their physical properties, and somewhere with the help of their chemical properties as well. So like making machineries, making automobiles, trains and aeroplanes, obviously, making cooking utensils and water boilers, making industrial gadgets and satellites. And even the students, you can see that metals is used up in the electricity as well, electricity purpose, because they are the good conductor of electricity. Exactly, good conductor of heat and electricity, so that's why we use metals at that point also. And even though metals like gold and silver, so they are used up in the formation of ornaments or jewelry, we can say, ornaments formation. So students, that's how, where we can see that metals are required according to their physical properties, that we require some hardness, we require some more tensile strength. Or if I talk about like they are sonorous in nature, I have given you one example, that in temples we are having bells, so you can do what do we say that, I don't remember the name exactly. Okay, no problem. So that's how, the where we require the hardness, where we require more tensile strength. So we use metal at that point, like making machineries. Generally, the machineries body are made up of iron only, because iron is very stronger in nature. Automobiles, trains, aeroplanes, they all are like automobiles. What is iron, and maybe the mixing up is also there. Cooking utensils we are having, water boilers, industrial gadgets, electricity. Gold and silver are also metals, and they are used up in the ornaments formation, jewelries we are using. But even the diamond is also used in the ornaments formation. But we are right now talking about the metals usage, like where you can use metals. Fine. So in the industries, metals are used up, even though in our houses as well. But if you talk about them, what are the uses of sodium and potassium? So I can't say, because they are very reactive. So we just keep them in kerosene, because if they are exposed to air, if we are making automobile from solar, which is not possible because they are very soft in nature, so that you can cut them with the help of knife as well, if you remember that exception. So that's how, student, uses of metals are here. Now we are having some question. Okay, so now what's the question is, give reasons for the following. Aluminium foils are used to wrap food items. Exactly. Aluminium foils are used to the wrapping of the food items. What's the reason about that? Because students, aluminium is malleable and soft. That means it can convert into the form of sheet that is soft and does not react with food items. So that's why we can use this metal as the for the wrapping of the food, and it can also keep it fresh. So because the heat will be there, because it is not going to pass out the aluminum foil, so that's how the food will remain fresh and somewhat warm also, so that you can eat it and have the same taste. Fine. So that is why aluminum is, first of all, you can say that its property is malleability, that it can convert into the form of sheet. So that's why we use aluminum for the wrapping of food generally. Okay. Now the another question is, immersion rods for heating liquids are made up of metallic substances. So, as we have seen that in the industrial gadgets for water boilers, we use metals, because metals are they are having high melting point and boiling point. So, when you heat any metal utensil, it just get heated up. It is not going to melt down, because their melting point is very high. So that's how immersion rods are made up of, like when we are heating any liquid, so they are made up of metallic substance, because they are the good conductor of heat and electricity. So immersion rods are made up of metallic substances. Fine. Because generally you can say that okay, even though what happened, for example, we are having immersion rods, and in winter season we generally use them to boil water. So when you boil it, the water with the help of it, so that is how they are the good conductor of electricity, and it is getting heated up because the heat is also getting generated. And one point is also there, that the melting point, boiling point, that the utensils which we use, which are made up of metal only, so they are made up of metal, so that's how they're having high melting point and boiling point. So when they're having high melting point and boiling point, so you are heating and you are cooking your food, they are not going to melt down. Exactly. But if you are cooking something in plastic containers, so it could not be possible because plastic is not a metal, है ना? So that's a student, you can see the immersion rods are made up of metals. Either you can say that good conductor of heat and electricity, and even though like metals are having high melting point and boiling point. But now if I ask one question here, that the metals which are having low boiling point and melting point, low boiling point and melting point, because we have discussed this thing already in the exception part. Do you remember which metals are those? So exactly, it is cesium and gallium. So these two are the metals which are having low boiling point and melting point. Fine. So students, that's how we have covered up all of these topics of this session. Now we just left with some few part, like 2 or 3 small topics, and with that we are going to complete that chapter. Now it's your duty to learn each and everything very carefully, learn your concepts, study very well. And after watching video, if you are having any doubt, you can post your question on public or private forum of askIITians, and you will be getting answers from expert side. And that's how we are completing our chapter in the next session only. Fine. So thank you so much for watching the video, and keep learning from askIITians. Thank you.